Hi everyone, welcome to Indonesia AI Summit. I'm very sorry that I'm unable to present to you in person, and hopefully presenting via video conference will work. My name is Barak Turovsky. I'm leading the Languages Artificial Intelligence team within Google Research, and one of the products under my responsibility is Google Translate. Hopefully many of you are users of this product. If you do, thanks so much for being one of the more than 1 billion active users of this product. I'm very excited to share with you how Google Translate uses cutting-edge AI to serve Indonesian and Asian users. First of all, let's start with the basic question why Google, and frankly many users, care so much about translations. And the answer is pretty simple. More than 50% of the content on the internet is in English. English is de facto the language of the internet. But only 20% of world population have any English skills, including basic. That means that many users from emerging economies like Indonesia, when they're able to access internet, they cannot use it effectively. Many of us were talking for many years about the barriers for usage of internet in emerging economies. And obviously the most obvious barrier is infrastructure barriers. For many years, users in emerging economies like Indonesia were not able to afford an expensive PC device to be able to access the internet. The cost of access of the internet was also pretty expensive. And thankfully, slowly but surely, thanks to Android and mobile phones, and cheaper internet access, this barrier of infrastructure is slowly going away. However, when users of those emerging economies are able to access the internet for the first time, they immediately encounter the language barrier because a lot of the content on the internet is in English. Therefore, for many of those users, internet is not a very friendly place to be. Therefore, for Google, a company who has a mission of organizing world information and make it universally accessible and useful, it's no-brainer that we are investing so much effort into Google Translate. And obviously it also explains why Google Translate is such a huge global product that loved by many, many users. Just to give you a sense of our scale, we translate 140 billion words every single day. Google Translate is by far the biggest AI project in the world. We have more than 1 billion monthly active users, and not surprisingly, 95% of our user base is coming from outside the United States. If you look at Indonesia or Asia Pacific region in general, this is the fastest growing and high priority region for Google Translate. Just some stats. In last 3 years, usage of Google Translate in Indonesia grew 5x. We currently support 3 Indonesian languages: Bahasa Indonesian, Javanese, and Sundanese. And Indonesia is the 3rd largest Google Translate market on Android devices. If you go to other Asian countries, obviously India is the largest, you can see that in last 3 years, usage of Google Translate in India grew 10x. Pretty impressive statistic. India obviously has more languages, more than 20 official languages, and Google Translate supports 11 of them. And India is by far the top translate country by usage. Another interesting stat is that usage of Google Translate on Google Search, where you can basically just say or type translate dog to Indonesian, grew 56x in last 3 years. So definitely India and Asia Pacific, it's the fastest growing and high priority area and region for Google. Another interesting thing about Google is that how much love we get from users and how much value users derive from this product. I'm so excited to get both electronic and written confirmations from users how valuable this product is for them. So this particular example, we received a physical letter to our team from a person of Indian descent who lives in Canada, and he had an arranged marriage with an Indian girl that lives in India, but they speak different Indian languages. I believe he speaks Hindi and his wife is speaking Gujarati. So they were not able to effectively communicate with each other, so they used Google Translate to communicate. And I really love the quote how he ended his letter. He said, "Google Translate gave me the best thing that has ever happened to me, love." We're really excited to get this reiteration from users how valuable this product is. We're using cutting-edge AI to enable magical experience. Obviously, you're familiar with use text translation on the right, but we also have additional magical experience. For example, visual translation, we called it WordLens, where you can just point your camera to a text, let's say a sign or a menu, and immediately translate it without the need to access the internet. It works on your device offline. We also have a feature that is translating conversations, where you basically can press the button, put your phone on the table, and use it as your personal interpreter. Translate is also available on many platforms. So obviously it's available on Google Search and also on translate.google.com website. It's available in Chrome browser, where you can translate entire pages. For example, if you access a page in English, but your native language is Indonesian, you can translate entire page. It's available on Android and iOS apps, where you basically can use Google Translate app to use those advanced features like speech translation or visual translation. And it's also available as an enterprise API, where third parties can use Google Translate API sold through Google Cloud to translate text in their own applications. For example, in this particular example, it's a WeChat application that uses Google Translate to translate chats within the application. If you step back, it's probably useful to understand on a high level how Google Translate works. So we use the same techniques Google uses for search, and we crawl the web to find content that was already translated by humans, and we use it as a training data to effectively learn the language. So in this particular case, for example, we look at the menu in English and Chinese, and we see that chicken is translated in the following manner to Chinese, soup is translated in the other manner, corn, cream is translated, etc., etc. And we will have hundreds of millions and billions of those examples. Then we basically, our algorithms can learn and observe those patterns and learn the language and to be able to effectively translate texts. One of the outcomes of this approach is that our training system is extremely susceptible to the amount of training data we have. We generally need to have billions of sentences of translated content, what we call parallel training data, to be able to effectively translate languages with good quality. And there are several languages, especially in Asia, that pose significant challenges for Google Translate. One of the biggest ones is India, where Indian languages have 3 out of top 10 languages in terms of numbers of speakers. Specifically, Hindi, Bengali, and Punjabi are top 10 languages in terms of number of speakers, and Hindi is the 4th largest language in terms of numbers of speakers. However, due to historical and social reasons, vast majority of internet content in India is in English, and there is not a lot of translations between English in those Indian languages. So that's created a significant challenge for us to be able to learn those languages. This is also true for other languages such as Arabic and Indonesian. So those languages required some creative approaches, how we can find and quote unquote fill the gaps to be able to effectively translate content for those languages. So Google Translate in 2016 launched a new generation of machine translation system called Neural Machine Translation. That was a big breakthrough for us. And it's probably useful to explain what was different in this system versus our previous systems. So previous machine translation system that was also pioneered by Google in 2016 was called phrase-based machine translation. This machine translation techniques also use machine learning. We call it old school machine learning or machine learning 1.0, in which we basically artificially break every sentence that we need to translate into chunks or phrases of no more than 5 words, since previous system didn't have the ability to translate more than 5 words at once. and would translate each chunk or each phrase independently of each other. That would create a pretty good scale of translations with this technique. Since 2016, we were able to scale to more than 100 languages that were supported through machine translation. But the quality was to some extent peaked after 5 years of work. Neural machine translation was really a game changer because it was the first commercial large-scale application of deep neural networks, what we currently call artificial intelligence, in which we are able to take entire sentence as a whole and rearrange it and translate it as a whole, as opposed to artificially breaking it into chunks. This created two big breakthroughs in terms of translation quality. First of all, obviously translation quality improved tremendously, between 50 to 80% across many languages. In fact, in one single launch, our quality of machine translation improved more than in 10 previous years combined. But what's equally important and maybe even more important and impressive is that we improved what we call fluency. It means that the translation sounded much more natural and much more human. Let me demonstrate it by an example between English to Indonesian. So this is an Indonesian phrase that is translated on the left with an old phrase-based machine translation and on the right with a new machine translation. As you can see on the left, old system was doing a pretty decent job of translating it. Around the world, people of various ages to rediscover the magic of ABBA music. However, as you can see, the sentence is grammatically broken and is not very fluid. And that's because we basically translate each phrase individually. Now, on the right, you can see what happens when you take the entire sentence as a whole. Then you can see much more natural and fluid translation. Around the world, people of all ages are rediscovering the magic of ABBA music. As you can see, it's fluid, it's grammatically correct. And that's basically the power and magic of artificial intelligence that allow us to dramatically improve both quality but also fluency of translations. This project was, as I mentioned, was the first big breakthrough of artificial intelligence in commercial large-scale applications. And when we were working on it, there was a tremendous excitement about this pivotal moment in the history of technology across many Google teams. And actually, when we started to work on it in September 2015, we expected that it will take us 3 years to launch the first language. However, we have so much excitement that we overcame enormous amount of technological challenges, and within 12 months, we launched the first language, and within additional 9 months, we actually launched almost all languages. All languages switched to neural machine translation. This is really an amazing achievement, especially given the fact how many complex tasks and challenges we had to overcome. I frankly don't know a lot of examples in which such a complex technical project was completed so much ahead of schedule. So we are very excited and proud of this achievement. So just to give you a sense of different challenges we encountered, one of the biggest challenges was scalability. As I mentioned, we translate an enormous amount of words every day, more than 140 billion. And initially, the training time to train those models at huge scale of billions of sentences for each language required, even in this Google supercomputer infrastructure, required more than 2 to 3 weeks per model, per language. Now, the models themselves were huge. It required us to have hundreds of millions of megabytes per model. And models, there was multiple combination of models. As you can imagine, we currently support 103 languages. If you want to support every possible combination of languages, you need to support 100 screen square. That means more than 10,000 combination of languages. That was extremely complex technological challenge that we had to overcome. And we had to innovate and find different ways to deal with it. One of the innovations happened on the hardware level, where Google developed their own proprietary and custom machine learning hardware called TPUs, Tensor Processing Units. And the first big client of Tensor Processing Unit was indeed Google Translate. Another thing we had to do is to innovate and create some new creative ways of using models so we can reduce the engineering complexity of our product. So in this particular case, we used what we call multilingual models. And let's look at the example where we have a task of training models for two Indian languages, English to Hindi, English to Marathi, and vice versa. So what we did to simplify our engineering stack, we basically combine those two languages, and in many cases much more than two languages, into one big model that were able to translate between English to Hindi and English to Marathi. And it was by doing that, we not only simplified our technical stack, but we were also able to create much better translation quality, because like with humans, when you know language A and you can translate between language A and language B and C, if you don't know language C well, machines were able to fill the gaps and basically learn between language A to B and language A to C to fill those gaps and be able to improve quality across all languages. And not surprisingly, languages that did not have a lot of training data were able to improve the best. So for example, in this graph, you can see that our old quality phrase-based in blue bars and neural machine translation new system is in red bars. As you can see, there was a lot of improvement on languages that were also decent quality before, for example, Hindi or Indonesian, but languages that were in pretty bad quality, for example, Marathi or Bengali or Telugu or Hungarian European language, those languages didn't have really good quality simply because we didn't have enough training data. And as you can see, we had pretty significant jump in quality simply because we use multilingual model in which computers and machine learning learn between languages and were able to fill the gaps where they didn't have enough training data. As you can see, Indonesian improved a lot, but also, truth to be told, it was in a pretty decent shape before, but now it's one of the highest quality languages in Google Translate system, which was really great achievements, and we are very, very, very proud of that. One interesting anecdote is that when we were training our models for Indian languages, one of the language we trained in was a language called Kannada with K, not to mix with Canada as a country. Kannada is the Indian language that has roughly 80 to 100 million speakers, and unfortunately there is a very abysmal, very small number of training data that we had. Given that, we basically mixed it with several additional Indian languages and we tried to see what will happen. Now, when we evaluate the quality of our new machine translation models, we first do automatic quality evaluation just to see if we're on the right track. And after that, we do human side-by-side evaluation where we'll show users the old translation and new translation and ask them to rate which translation is better. So in case of Kannada, we initially got very promising results that the quality is improving tremendously. But then when we sent it to human raters, we got a very surprising response. Kannada speakers among our raters told us the quality didn't improve at all. Moreover, the quality and translation quality was identical to our previous system. That didn't make a lot of sense to us, so we started to investigate. And what we figured out is that the researchers that was training those models messed up the languages. He trained on the wrong language. Instead of training it on Kannada, he accidentally trained on a completely different language, Georgian. As you can imagine, Georgian has very little similarity to Indian languages, but regardless, when trained with Hindi, the quality of Georgian improved so much that we actually launched it. That led us to an interesting conclusion that it's actually not that important to train models, multilingual models, on languages that are linguistically similar to each other, meaning they're coming from the same linguistic group. And what's much more important is to try and iterate and mix languages that have a lot of training data with languages that don't have a lot of training data. We call it low resource languages. So just to prove the point, we iterated and tried to mix Polish and European languages that has a lot of training data with a couple of Asian languages, Thai and Vietnamese, that don't have a lot of training data. And the result was pretty amazing. Both of those languages improved so much and we were able to launch them. So that's actually proved the point that a multilingual training approach works, and two, that computers were able to find higher level similarities between languages in different linguistic groups that humans were not able to pick up ever, and basically were able to learn and improve translation quality across those languages. We call this phenomenon interlingua, quote unquote. It's more of a joke definition, but what it means is that simply computers were able to find those similarities across languages that humans or linguists were not able to pick up. So that was a very interesting, let's call it take a bug and make it a feature. So we basically had a mistake that actually led to very interesting scientific discovery. So that was one of great achievements that we achieved, but we actually thought, what can we do more? And we started to think about a use case where you again train multiple models at once. So let's take this example in which we train between English to Japanese and English to Korean and vice versa in one big model. We thought, what else can we do with it? And we thought about a use case where you actually need to translate not between English to Korean and English to Japanese, but you need to translate between Japanese and Korean Korean to Japanese. So the interesting thing here is that we actually had zero training data between those two language pairs, because it's not most of the human translations on the internet are between English and different languages. So if you want to translate between Japanese to Korean, we started to think about a concept that is called zero-shot translation. Like with humans, if you know English, Japanese, and Korean, you'll be able to translate obviously between English to Japanese or English to Korean, but you also will be able to translate between Japanese and Korean or Korean and Japanese. That's what we try to do with zero-shot translation and see if machines could apply the same approach, and it looks like it's working. So this is something that is area of active research for us, and we are very excited about this development. Another thing we are doing is that, as I mentioned, we mostly use machines to crawl the web and find human translations, and this works pretty well at large scale, but sometimes computers and machine translation needs a little help. And specifically, one area that machines are not very good are culturally specific translations. For example, poetry, or for example, jokes. In those cases, you cannot just literally translate it. You really need to be able to be immersed in the culture of this language to understand those type of translation. And that's where actually having human translator is the best. So we leverage the large army of language enthusiasts in many countries who are excited about their language, and we'll provide them tools to improve translation quality for their own languages. We launched this project in July 2014. Ironically enough, it was in response to very strong user requests from many countries where people, language enthusiasts, asked us to launch new languages. For example, Kazakh or others. And we basically created this micro tasks like Wikipedia, in which some language enthusiasts contribute translations to us and others are rating them to make sure the translations are correct. So since our launch, we have more than 700 million words that were contributed to this effort across 120 language pairs, and it allowed us to launch new languages like Kazakh, Singhi, Sinhala, and others to basically expand number of users that we serve on Google Translate. Another amazing thing about this approach is that the quality of translations were higher than paid translators, meaning that our volunteers who are excited about their language were able to provide us better quality than if we would pay professional translators to translate those sentences. That was great. It's a great attestament of the power of crowdsourcing when people find the great cause of helping Google Translate launch or improve quality of their own language. This concludes my presentation. Hopefully you enjoyed it. Thanks again for your patience, and I'm more than happy to take any questions you might have. Thanks again.